All right, now I'm going to show you what happens when we try to take an infinite sum of a geometric series. So here's our equation right here for a geometric series. And it has this term, r to the n. Well, what if n is infinity? Well, if this guy is a number bigger than 1 or less than -1, then this guy's going to explode. Okay, it's going to get huge. But if this guy is less than 1, and we start multiplying by it over and over, like 1/2 times 1/2 times 1/2, this guy is actually going to get close to 0. So basically what happens is this guy goes away. And our formula gets much simpler. Again, this only works when r is less than 1 and bigger than -1. So, for example, this guy right here, this infinite sum, we start with 100 and our ratio is 1/2. So that works for this. So we just say 100 minus 1 minus 1/2, 100 over 1/2. This will add up to 200. And that makes sense because this is getting smaller and smaller and smaller as we add it up. But if we've got something like this, our ratio is 90 over 60. It's 3/2. This is bigger than 1. This keeps getting bigger, 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 bigger. This also works if it's this also has the same problem if it's a negative ratio. So it'll just keep moving back and forth rather than converging to one little thing. So this one diverges.